Okay, let's look at an illustration of the other three transformations. So we illustrated in a different video the vertical shifting when we have this plus d when we're adding a constant. Okay, in this graph, what I'm going to do is activate this other graph down here where instead of adding, I've now put a constant in front of the function. Notice, okay, it's not inside parentheses; it's in front of the x squared. And we talked about it here when we were discussing the function notation. Every time there's a number in front of the function, we're doing one of these three, possibly a combination of two of them, but we're doing one of these three transformations. It all depends on what the value of that number is. Okay, is it greater than 1? Is it between 0 and 1? Or is it negative? So let's take a look. So I've got this a value here, and I've got a slider for a. So right now a is 1, right? So that's why we don't see a different graph. If a is 1, then this is just x squared. But if I increase the value of a, look at what's happening to the graph. Okay, so you can see it's getting thinner, right? And what I've always said when I have this object in front of me is think of a rubber band. Okay, think about you're holding a rubber band. Here's your thumb and here's your index finger, and you're pulling down, okay, on this rubber band. If you take where you're pulling and you keep stretching it down, okay, that rubber band is going to stretch vertically. So think of that parabola, think about that vertical stretch, okay, as making that graph thinner, because that's really what it's doing. That's what a vertical stretch is. It's thinning. It's making the graph increase more quickly. All right. So that's why we say it gets thinner like this. So this is an illustration of a vertical stretching of the graph. All right. Let's bring it back to 1. So you see here again, this is our regular basic parabola. Let's use an a value that's less than 1. What happens to the function? We see that it starts to bow out a little bit, okay? This is an example of a vertical compression, okay? So we're seeing that graph sort of bow down, okay, and unfold. So I sometimes refer to this as a vertical squash, because think about the red graph that you're looking at right here. Think about that as like a piece of like a bendable plastic, and you're pushing down from the top. What's going to happen? It's going to start to bend down, right? So that's an example of a compression, vertical, what we call a vertical compression, okay? If a becomes 0, we have a straight line because there's nothing there, right? This is our purple graph if a is 0, right? So there's our vertical compression for values of a. You'll notice again, when this value of a is between 0 and 1. All right, what happens when we go negative? Right? Bloop. We get that flip. So if you remember from before, anytime the number that's in front of the function is negative, we flip over the x-axis. Okay? When the number is between 0 and 1, we get that compression. When the number is greater than 1, we get that stretch. So that's what we're seeing here. Okay? A value greater than 1 is a stretch vertically. A value between 1 and 0 is a compression vertically. And as soon as a becomes negative, as soon as this number right here is a negative number, as soon as this number right here is a negative number, we get that flip over the x-axis. So this is an example of our 3 other vertical transformations, okay?